In this video, we will be talking about polyatomic anions and their nomenclature. Polyatomic ions are merely ions that contain more than one type of atom. Most of the polyatomic ions that we will be working with will be oxyanions. These are anions, which are negatively charged ions, that contain oxygen and another element. Notice when we're looking at a particular series that when a series of oxyanions contain a different number of oxygen atoms, the oxyanions are named according to the number of oxygen atoms in the ion. If the series consists of only two ions in the series, then the species that has more oxygens will take on the ate, ATE ending to the name, and the one with the fewer will be ite, ITE. Some examples of this are the nitrate and nitrite anions. Note that they both start with NITR, and then the ending is ATE for the one that has the 3 oxygens, and ITE for the one that only has 2. Similarly, we have sulfate and sulfite. Sulfate is SO4 2-, and sulfite is SO3 2-. They both start with the SULF prefix, and then the end, ATE, goes with the one that has more oxygens than the ITE. If there are more than 2 ions in a series, then the prefixes hypo, meaning less, and per, meaning more, are used in addition to the ite and ate. Looking at a series where we have an increasing number of oxygens bound to chlorine, the two that we were previously talking about are the more oxygenated and less oxygenated, the one that has the ate and the ite. So ClO3 is the chlorate ion, ClO2 is the chlorite. If we go 1 oxygen less than the ite ending, then that would be the hypo. Then you indicate what the central atom is, and then followed by the ite. So we would have hypochlorite. For something where there are extra oxygens, more than the regular ate ending, so more oxygen than the chlorate, you put a per in front of the chlorate, and so this would be perchlorate. So in order of increasing number of oxygens, you have hypochlorite with 1 oxygen, chlorite with 2, chlorate with 3, and perchlorate with 4. Similarly, for a bromine compound, we have hypobromite, which is BRO minus, bromite, BRO2 minus, bromate, BRO3 minus, and perbromate, BRO4 minus. In your scientific career, you will come across many different polyatomic ions, and there are some that you will encounter more than others. In this table, the ones that are indicated in red are the most common polyatomic ions that you will come into contact with, particularly in a general chemistry setting. We have the bicarbonate, carbonate. The difference between the two is the bicarbonate is HCO3-, and carbonate is CO3 2-. Hydroxide is very common, and this one will be OH- would be the polyatomic ion. We have nitrate, which is more common than nitrite, but if you know nitrate, then you can figure out nitrite based on what we said on the previous slide. We have phosphate, sulfate, and sort of an odd one out is the ammonium ion. This is actually a cation, whereas the others are anions. This cation will be used particularly when we're talking about solubility in the next semester of general chemistry. So ammonium would take the place of the metal in an ionic species. So we could have something like ammonium phosphate, where we have this ammonium combined with phosphate ions. So ammonium here will take the place of the metal in an ionic species. Looking at how we would use these in terms of naming, ionic compounds that contain a polyatomic ion rather than a simple ion, such as the chloride, are named in a very similar manner as what we saw for the binary compounds, except that the name of the polyatomic ion is used. So In our previous example, we could have had something like sodium chloride, where you take the sodium, the metal is being named as is, the chlorine loses the end part of its name, the "-ine", and you replace it with "-ide", so it becomes chloride. So NaCl goes from sodium and chlorine to sodium chloride. For our polyatomic ions, we don't change the end of the name. We just use them as is. So for example, we could have NaNO2. This NO2 is the nitrite polyatomic ion. Na is sodium, and so when we put the two together, we get NaNO2 is sodium nitrite. You name the metal or the cation first, and then the anion. For polyatomic ions, you leave the anion's name as is, and you just put it at the end. So we have sodium nitrite would be NaNO2.